Okay, example 2 has us graphing a reciprocal function by using a table. They give us the function g of x, which is defined as 1 over 2x minus 5 plus 2. I want to first identify some key features, like the asymptotes, the domain, and the range. So determining the vertical asymptote, we find our excluded value. So 2x minus 5, how do we get this whole thing to equal 0? Well, if x equals 2.5, right, half of 5, and we multiply it by 2, then we'll get 5 minus 5. That equals 0. So x cannot be 2.5. If you go down to their graph, 1, 2.5, that is where you're seeing their asymptote, their x-axis asymptote, right? X cannot equal 2.5. Now for the y-axis, we just want to think, simplest way for me to think about this is what happens as x gets really, really big. So if you imagine x going all the way to infinity, well, then you have infinity minus 5 on the bottom. That's just still going to be kind of infinity. We're still going to have some giant number on the bottom. And 1 divided by that is going to get us very close to 0. Okay, it's not going to get us to 0, but it's going to get us to some infinitesimal amount that we don't really have to think about. So we are approaching a value of the function g of x equaling 2 in the long run. As we go out to the right, we are approaching the value of 2. We never get there, but we get very close. And we get closer and closer the further we get. So those are two important parts, is your vertical asymptote and your horizontal asymptote. Beyond that, we can look for points to graph, such as the x and y intercepts. It's, always a good place to go. So doing that, we would say, okay, if I want to know where my graph runs into the y-axis, that is when x equals 0. So our x, where x equals 0, our y-intercept here would be like g of 0. So this would be our y-intercept, right? Would be when x equals 0. And our x-intercept is going to be when the function equals 0. Okay, so that's going to be our x-intercept. So in this case, on the y-intercept, we're going to have 0 comma something. And for this one, we are going to have some value for our x-intercept, and our output should be 0. Okay, so if we wanted those 2 points, we could do that. We could write out when x is 0, the function would be, well, what would it be? It would just be 1 over negative 5 plus 2. So I'm going to call that 2 minus 1/5. If we want the whole function to equal 0, then we're going to have 0 equaling 1 over 2x minus 5. We're going to subtract the 2 on both sides. We're going to multiply by that denominator and then distribute once we've done that. All right, and we're just going to go through all of our kind of normal algebra steps to get a solution here. Okay, so we could do that. They're also just suggesting that you would go in and you'd find points slightly to the right and to the left of that intersection of the asymptotes, and you would plug those into your function and you would find their outputs. So nothing really too complicated here. Just the most important parts is establishing where those two asymptotes are, which once again was from finding the excluded value on the bottom. That'll give you your vertical asymptote that's touching your x-axis. And then just imagine what's going to happen to this whole thing when x gets massively big. That will tell us our horizontal asymptote, what we're approaching in the y direction. Past that, it's all just, putting in points and finding where they are to graph them. Nothing too complicated there that you really need an explanation for.